Hi everyone, Steven here. Welcome to another MATLAB Crash Course lecture series. Today we're going to be discussing while loops and everything while loops entail. So let's kind of look at what we're going to talk about today. So the purpose of while loops, that's what we're going to start off with, when to use while loops, why we want to use while loops. We're going to then look at using while loops and the syntax with it, how we'd want to set a while loop up. We're going to look at counting in a while loop and how we can actually count the number of times we go through a loop. We're going to look at error checking with a while loop and how we can use a while loop to look for errors that the user may enter. Then we're going to look at using a Boolean variable as a condition for a while loop. That might not make too much sense right now, but it will later. And then finally, we'll close by looking at some infinite loops. And we're going to have a few examples along the way. Now, if you remember our last lecture series, we talked a bit about for loops. And now while loops are a little bit different than for loops. And we're going to see exactly how they're different. So as seen in the previous lecture, for loops can be used to repeat specific actions for a known number of times. However, there may be cases where we want to repeat an action for an unknown number of times. So for loop is really useful when you know exactly how many times you want the loop to run through. If you have a loop and you want to run through it 5 times, you can simply say for I equals 1 through 5, and then put your action and it will loop through exactly 5 times. But there may be some times where you actually don't know how many times you want to loop through something. You want to loop through something until maybe something happens or some condition is met instead. And a for loop cannot be used for that. A for loop will not actually work, and you'll be stuck trying to find a way to use a for loop to do something that you can't use a for loop for. So instead, virtually every programming language instead has another type of loop. And this type of loop is known as a conditional loop. A conditional loop, as the name implies, says, okay, we're going to keep looping through this action or whatever we want to happen. We're going to loop through until a certain condition is met, as opposed to a for loop where you loop through a specific number of times. Conditional loops, known as while loops, allow for an action to be repeated when the programmer doesn't necessarily know the number of times the action is to be executed. So a while loop, as the name implies, says, okay, while this certain condition is true, keep on looping through that while loop. And then once that condition is not true, we're going to stop. So let's actually take a look at using while loops and how we can use them. So the block over here represents the basic structure for a while loop. It's very straightforward. So we got the keyword while, and then you place a condition. The condition is here, like similar to like an if-else statement. The condition must return a logical true or false value. So what you end up putting in here is while some relational operator or logical operator, something that will return a true or a false. You put that in your while loop. Then you replace an action in here. This is the action that is to be repeated. As long as the condition specified in the while loop is true, the action will continue to be repeated. And then you place end here. So what ends up happening is we have a condition. This condition, it's going to look very similar to a condition in an if-else statement. So like if you say if the value is greater than 0, where value is some variable. If value is greater than 0, keep on performing this action. As long as that condition is true, the while loop will keep going. And then once this condition here, this relational operator or logical operator, once it returns a logical false as opposed to a true, the action is done. And the while loop will cease to keep on looping. So let's see. That is exactly what I wanted to say. The general format for the condition will be a relational operator, like I talked about earlier, or a combination of relational operators, including generally some defined variable. Actually, just about every time. So you'll have a condition in here, and this condition will include some variable that you previously defined, and that variable will keep on changing. Since the loop will continue if the condition is true, the variable in the condition must change in a way such that the condition will eventually be false. I'm going to explain what this means in 1 second with an example. Once the while loop is terminated, the rest of the code will be executed as normal. So let's go back to this first one up here. So we say the variable of the condition. So in this condition, we have some variable. You have to have some variable, and we'll see why in a second. And that variable has to change. It has to change in some way, or else that condition is never going to end up being false. And this is going to run into some problems. The last slide is actually going to show what exactly that problem is. But so let's look at a couple examples here. So let's see, I've got a few here. So let's look at this. So printing numbers.m. So here's kind of how we would want to use a while loop. So this script will simply print off the numbers from 1 to 10. That's all it's going to do here. Nothing too extraordinary. Let's see. Use a while loop to print off the numbers. Initiate the variable that will be used in the condition. So here we start by saying value equals 1. This is going to be the first value we print off. So we initiate it and say value equals 1. Then we say, while the value is less than or equal to 10, we're going to print what that value is, and then we're going to increment the value by 1. So what we can see here is that this loop is actually going to keep going through, and every time it goes through, it adds 1 to that value. So we have 1, then 2, then 3, all the way up to 10. And then once it gets to 11, because it'll add 1 more to it, once it gets to 11, it's going to go back up to this condition here and say, okay, we're at 11. Is 11 less than or equal to 10? It most certainly is not. It's going to cut off that while loop, and then we're going to execute the rest of the code as normal, meaning it's going to print this finished right here. So let's actually see this in action. So if I type printing numbers, so we can see it does exactly that. It prints off the 1 through 10, and then once it reaches 11, because it adds 1 more, that condition up here that we saw, this value is less than or equal to 10, it takes a look at that and says, well, that's going to return a false because we're at 11 right now. The while loop is finished, it's terminated, and then we continue on with our code. Now, what would be the benefits of using this as opposed to a for loop? There actually are no benefits. For this example here, you'd actually want to use a for loop. I was just showing this as an example of a really basic example of a while loop here. But in this case, you'd rather use a for loop. If you want to print from 1 to 10, just use a for loop from I equals 1 to 10, print off the value. That's going to be a heck of a lot less trouble there. But so let's look at an example where a for loop would not help. So here I have another script called half.m. So this script will take an input number and keep printing the result of dividing it by half until it reaches a number that is less than 1. So this is a little tricky here. So in this case, we start with a number that the user enters. It's then going to keep dividing by 2 and printing the value on the screen. It's going to keep dividing by 2, and we want it to keep going and dividing by 2 and printing the value until it gives us a value that is less than 1. How are we going to know when it's less than 1? We can't know with a for loop. A for loop, we have to know a specific number of times, unless beforehand we want to do the math and know exactly how many times we're going to have to divide by 2. That's a lot more work for the computer. It's a lot more work for you. You have to figure out the math and the algorithm to develop all that. Instead, we can utilize a conditional loop instead with a condition that the value we're at has to be greater than or equal to 1. So we start by asking them for a value, and then for our condition here, we say, all right, let's take that value. While the value is greater than or equal to 1, we're going to go ahead and print that value to 3 decimal points, and then we're going to divide by 2. Then it's going to start again. It's going to look at that division by 2. We say value equals value divided by 2, meaning value is replaced by what it was previously divided by 2, and we're going to keep looping through. All right, what is it now? Is it greater than or equal to 1? If it is, keep going. Once it is less than 1, that's when we stop our while loop, and then it's going to just print off finished here. We have to use a while loop instead of a for loop because we don't know how many times it's going to loop through. Every time the user enters something, that's a different number. But a while loop allows us to make it very straightforward, very easy. We know that we don't have to know how many times it's going to loop through. We don't need to. Instead, we can just simply proceed with the division, and then once it's, greater than or equal to 1, or once it's less than 1, we stop that while loop. So let's actually take a look at this one here. Enter the starting value. Let's do 3,000. I couldn't tell you how many times it would loop through this, but I don't have to because MATLAB just does the division for me. When we divide this number by 2, we get a value that's less than 1, so it cuts off and it finishes. Very straightforward. While loops are kind of a miracle worker in that it saves a lot of the computation that the user would have to do. Let's look at another example for our own. So create a table that will list the areas of circles starting with the radius 0.1, incrementing the radius by 0.1 until the area of the circle has reached an area greater than 5,000. So once again, this is another example of how we'd have to use a conditional loop instead of a for loop. Why can we not use a for loop here? Well, we don't know exactly how many radiuses or radii with circles we're going to be printing. We don't know that number. All we know is we want to keep printing until the area is, once that area is greater than 5,000, we want to stop printing. That's all we know. We don't know anything about, we could do the math and try to figure out how many times that would be, but that's more work we have to do. With a conditional loop, we don't have to do that work. All right, so let's create a new script here. Oop, not that. Let's do a new script. Let's save it. We're going to save it as area table. You'll see I have area table.count. That's going to be for something later. So what's the script going to do? This script will print off the radii and the areas of circles until the area has reached a limit of 5,000. All right, so what's the first thing we're going to want to do here? Well, so we're going to want to, we don't have to ask the user for anything because it's just normal. So we're going to set initial values. All right, so what are the initial values we're going to look at here? Well, we know based on here that we're going to start with the radius of 0.1. So that's going to be important. Actually, you know what? Let's not start with our initial values. Let's start by print header. So we're going to print our header, meaning we're going to say, make it look nice. So we're going to say radius and then area. All right, and then let's do some equal signs to make it look like a table because that's cool. The UNL police wants to talk to me. Hopefully I'm not in trouble. That was just a joke. Let's see what else we got here. So we print our header. All right, now we want to set initial values. So what are the initial values we want? So we said we're going to start with a radius of 0.1. We also should know the area going off because with our conditional loop, we need to compare the area. So we should calculate the first area and we should look at the first radius. So we want to say radius is going to start by equaling 0.1. And then that means area is going to be, well, it's going to be pi times that radius squared because that is the area for a circle. All right, so I got that here. Now what are we going to want to do? Well, so we want to print that value. We're going to want to increment the radius by 1. We want to check to see if that new area, whatever we get when we, add a 0.1 to it, whatever that new area is, we want to check to see if that area is less than or equal to 5,000. If it is, let's calculate the next area, print that value. So what should we do first? Well, let's initialize or use while loop to print values and perform calculations. All right, so we're going to say while, what's our condition here? Until the area of the circle has reached an area greater than 5,000. So that's not the condition. We don't want to say area is greater than 5,000 because that means we're going to loop as long as the area is greater than 5,000. We want to say the opposite of that. We want to say while the area is less than or equal to 5,000, meaning as long as that condition is true, meaning we want it to be less than or equal to 5,000, we're going to proceed with the following steps. What do we want to do? Well, first we want to actually, print this radius and its area to the, to the command window. So let's see, we want to print the radius and the area. So we're going to start by printing the radius. Let's have it go. Okay, let's see. How many spaces do we want here? We want 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. All right. So we're going to proceed with 16 spaces. And we're going to put off 1 decimal point. F. And then we want to print off 3 decimal points. What are the two values we have here? The values that we're going to be printing are going to be the radius first, and then we're going to print the area. All right, so after we print it, we need to calculate the next radius and the next area. So the next radius is easy. We're just going to take our previous radius and add 0.1 to it. To find the area, we do that same calculation. We take pi times our radius, the radius being the new radius where we add 0.1, and we're going to square it. All right, and this should be everything we need. So let's actually see if this works the way we want it to. So let's clear that area table. All right, so you can see here, we've got a lot of different values here. We got a bunch of values. So we started at 0.1, and everything looks pretty nice here overall. We probably could have used one more equal sign. So we had a radius of 0.1. It calculated the area. And it kept incrementing by 0.1. So we have a giant table of radii in the respective area until we get to what looks like 39.8. And it prints us this value. And if you see, it would kind of make sense. If we went one more number further, we went to 39.9, we would most likely get to a value above 5,000. So it cut us off before we reached that value. We couldn't do this with a for loop. Unless you knew, you would have to do this what appears to be, looks like 398 times. And I don't want to calculate that, and you probably don't either. So using a while loop is a lot more efficient in this case. All right, counting in a while loop. So unlike for loops, while loops don't automatically indicate the number of times an action will be executed. That is one kind of hindrance with using the while loop. You don't know how many times something happened necessarily. With a for loop, you can just print your variable of iteration that tells you how many times it's going to go through. If the number of loops executed must be known, like if you want to know how many times the action was completed, but a while loop must also be used, meaning you have to use a conditional loop, one must use a variable as a counter. So simply initialize this counter that we have, or some variable that just counts how many times it goes through. So just initialize it as 0 at the beginning. Then at the end of each while loop, increase the variable count by 1. So it kind of is a little intuitive here. So if we want to count how many times the while loop goes through, start by saying count equals 0. When you go through the the while loop, by the end of it, increment count by 1. So every time it goes through that while loop, you're going to add 1 to the value of count. And then at the end, you can display count or do whatever you want. So that's what this area table count is. So this is the exact same thing as last time, except I did a little bit different this time because you can tell by this loop we printed 398 times because, we went by 0.1 and the value is 39.8. So that's not very fun. But let's say the radius we wanted to increment by was 0.05 if we wanted to add 0.05 each time. What would be different here? Well, so we're using 0.05 instead. But this time we want to count how many times the while loop executed. We want to count how many circles are in our table. So we start by saying count equals 0 to begin with. We do the rest of our code as normal. We have everything. This was initializing our counter. Oop, I don't want to mess anything up. We initialized our counter, and then we incremented our counter by 1 every single time. We added 1 to it. And then at the end, we actually printed total circles, and we're going to print our variable count here. So let's see what happens if we do this. So area table count. So here we incremented by 0.05 instead, and says the total number of circles we have is 797. So we used our counter to tell us, okay, how many circles are in this massive table of values we have? And it worked. We have 797. So using a counter may be essential at some points. Generally, it's not too necessary, but if you need to know how many times you execute an action, a counter can be used in a while loop. Error checking with while loops. So many applications can utilize while loops to make sure that a certain correct type of value is entered. This is kind of called error checking in this case, but you can use a while loop to make sure that your user is doing what you want to do. While loops can be used to check any errors that the user may make when entering values into a program. The user may enter the value from the start. If the user enters a value that isn't correct, the while loop can be used to keep asking for a value until the user enters a value that works. Once the user enters a correct value, the while loop will break and the program will continue. So this is just a lot of words that I have on here. Let's actually see what I'm talking about. So what we're looking at here is basically you ask the user for a value. If the user enters a value that just doesn't work, like let's say if you're trying to calculate the volume of a sphere and the user enters a negative number, instead of just ending the program right there, we can have a while loop go through and keep asking the user for a value until the user decides to enter a positive number instead of entering a negative value. So let's see this example here. So sphere error test. This script takes user input to calculate that volume of a sphere. It should be just the volume. It also checks to see if the user entered a positive number and will keep asking until the input is positive. So we say enter the radius for the sphere and we ask for the radius. But then before we just calculate the volume, we have a while loop here. And this while loop says while the radius is less than 0, meaning if they inputted a number that was less than 0, let's execute this loop. We're going to print out please enter a positive value. Then we ask for the radius again. We say enter the radius for the sphere. And if the user enters a negative number again, guess what? When he goes to this while loop, it's going to execute it again, and it's going to ask him again to please enter a positive value. And it's going to keep doing that until the user finally caves in and enters a positive number like they should have in the first place. So let's see. Hopefully this all makes sense here. You have your radius, enter the radius, and then this while loop is purely used to see if they entered a negative number. If they entered a positive number from the get-go, this while loop will never be executed. But let's see it in action. So let's see. Enter the radius for the sphere. All right, let's say the radius for the sphere is going to be 4. All right, cool. We automatically got the value of our sphere. That's cool. We didn't have to do any of that weird error checking stuff. But let's say we run it again. Sphere error test. And let's say we enter instead -1. So this is where the error checking comes in. We're now in that while loop where it says, please enter a positive value. Enter the radius for the sphere. If I enter another negative number, it's going to go through again and ask me enter a value. I could put another negative number and another negative number and another one. And it's going to keep me in this while loop until I finally cave in and give them a number they want. And then it's going to calculate the volume. A for loop cannot be used for this because, once again, you just want to do it as long as the user's not behaving. There's no other indicator. You can't know how many times this is going to happen. You can't know if it's going to be 0 times they're going to enter something wrong or 500 times. But a while loop, you don't have to know. You can just do it. All right, now we're going to look at using a Boolean variable as a condition. So in all these examples we've had so far, we've had some kind of relation indicating our condition, like value is greater than or equal to 0, or area is less than or equal to 500 or 5,000. But you can also have a Boolean variable as a condition. So instead of placing a condition with a relational logical operator at the beginning, one can place a logical variable. This can be useful when wanting to program to continue indefinitely until a flag is triggered. So if you have a program you want to write and you want to keep continuing and you want it to just keep happening until some kind of flag is triggered or something happens, this can be useful. This is common for programs such as executable programs where you want the program to continue until the user exits. So like, kind of think about it like this. For an executable program, we want it to keep being up and running the whole time until I click the exit button. When I click the exit button, that's kind of like the flag that gets triggered and say, okay, they clicked exit out of the while loop in that case. Initialize the Boolean variable as true before the while loop, then have an if-else statement at some point in the loop to set the variable to false. This will finally cut the while loop and the program will continue as normal. So this is another way of just thinking about a conditional loop in this case. A lot of times when you have a flag, you could still use a normal condition, but sometimes it's cool just to think about it as terms of a flag. And sometimes people will think it easier as a flag instead of as a relational operator, and sometimes it can be nicer. So here's an example I have. So calculating a user input running sum. So if we go to MATLAB over here, I have, let's see, I should have user sum. Here we go. This script will ask the user for values and keep a running sum. The running sum will continue until the user enters a 0. So what we have here is we're going to ask the user for values. We're going to keep adding all these values, but once the user enters a 0, we're going to indicate that that means that they don't want to add any more numbers, and then we'll print the final sum. So what we do first is we initialize our Boolean variable as our flag. So we're going to say calculate this variable we have to be true. And I kind of am naming variables in terms of English a little bit. I want to say calculate, meaning we want to keep calculating the sum to be true. So while we want the sum to be calculated is true, we're going to keep adding numbers to our running sum. We start with sum equaling 0 because we need something to start with for our sum. We say we get a value from the user, a number that's an integer. If the value is equal to 0, we're going to set the flag to false. If it's not equal to 0, we're going to add the value to our sum, just like this. So here, this is the if-else statement we're talking about. Here is where we set the flag to false. So if the value is 0, we set calculate to false. So when it goes through the while loop again at the top, calculate will be false and the while loop will not be executed anymore. At the end, we print our total sum. So let's see this in action. I'm going to keep this up while we're doing it. So enter a number to add. We'll start with 4. Cool, but we're still in our while loop because the flag was not set to false. So then let's add another number and another number. We can keep adding numbers. I can add a negative number. And this while loop is never going to exit because our flag is never going to be set to false, ever. Until I enter a 0. Once I enter a 0, then it cuts off my while loop and it tells me that my total sum is 385. So having a flag in this case can be useful. We could have used just a normal while loop with a condition. This is just another way to think about it. You may run at some point in your code that it's easier to think about it in terms of a flag instead of as some kind of condition. All right, now I have a couple examples I want to go through before I talk about the last subject. So example 2, this is a little fun one. Create a guessing game where the program we have picks a number between 1 and 100 randomly, and the user must guess the number. The user needs to try to guess the number in as few tries as possible. At every guess, the program tells the user whether their guess was too high or too low. At the end of the game, the program asks the user if they would like to play again. So we're just kind of playing a little guessing game with ourselves for MATLAB here. So we're going to have MATLAB guess a number or pick a number between 1 and 100, and we want to find that correct number in this case. So let's see if we can write this program. So let me make a .m file. Let's call it guessing game. This script is a guessing game. The program picks a number between 1 and 100, and the user must guess the value in as few turns as possible. All right, so what should we do to start? Well, we should first start by choose value to guess. So let's see. Let's name this value. So this is the value that they're going to want to have to pick. Well, we want this number to be random. We don't want it to be the same every single time or else they'll know the answer. So let's make it a random value. So randi 100. If you don't remember what randi means, remember randi is just a simple function where you enter an upper bound and it's going to print off one number between 1 and that upper bound you set. It's just going to return a single value, and it's a random value using pseudo-randomness, that is. So here we're going to have a random number between 1 and 100 pick. So then we're going to say ask user for a value. So here, let's try to make it a flag here, but also we need to remember that we're actually, this is one thing I actually forgot. We need to remember that this whole thing is actually going to be in a continuous while loop, because you remember description. At the end of the game, the program asks the user if they would like to play again. If they would like to play again. If they don't want to play again, then it's going to shut off. But if they do want to play again, we need to actually get a new value of 100. We need to get a new random value here. So actually all of this, I'm going to tab over, because initialize first while loop. So we're going to have a little flag made. So I'm going to make a variable called continue. I guess I'm not going to make it called continue because that's a keyword actually. So play again is going to be our value, and we're going to set it to be true at the beginning. This is going to be a flag that we have. And we're going to say while play again, we're going to keep going through this loop that we have. This will make more sense in our final product, but basically we want to, if this value is true, we're actually going to start the game over again. But if they don't want to play again, we'll set this flag to false and it'll cut off the game. So we have that. Then we're going to choose a value to guess. So we choose a value using the randi. Now we're going to ask the user for a value. So what kind of value how should we ask them for this value? Well, what we want to do essentially is we want this whole thing to be in a while loop because we want to keep asking them for values. So we're going to say while, and then how should we set this up here? Well, we can set this up by saying while, whatever value they pick or whatever the user inputs or whatever their guess is not equal to the value, we want to keep this while loop going. So we could try to do this. We could say like guess equals value, but if you look at this, guess would be the number that the user guesses, but we don't have a guess yet. We'd have to ask them for a guess in here, and then we'd have to write another guess in here. What would be easier for us, as you'll see, is if we actually use another flag. So we have one flag here that says play again. Let's have another flag here called correct value equals false. So correct value is a new flag here. So value is the number that they're trying to guess. Correct value is a flag asking, okay, do they have the correct value? We're going to start by saying no. When we start off, we don't have the correct value. So we're going to say while not correct value, meaning while we currently do not have the correct value, because not correct value, at first it's going to be false, but when we put our not operator in front of it, it's going to be true. So we're going to say while it is true that this value is false, we're going to continue on with our guessing game that we have. So what do we want to do first? First, we want the user to provide a guess. So we're going to say guess is going to equal input, enter a guess here. And the user has to guess a value between 1 and 100. Enter a guess here between 1 and 100. So they offer a guess here. So once we have our guess, what do we want to do? Well, we want to see if our guess is correct at all. So let's use an if-else statement, because one of three things could happen. Either the user enters a value that's too high, either the user enters a value that's too low, the user enters the correct value, or they could enter a value that's actually not in our description at all, meaning they enter something above 100 or below 0. But let's not worry about that edge case right now. Instead, let's just consider it's either too high or too low, or it is the correct value. So if guess is greater than value, meaning they guess too high, f print f, your value was too high. Or I should say your guess. Your guess was too high. And that's all we're going to do. And then it's just going to go back to the while loop. Then we can have else if, let's say their guess was too low. So their guess is less than the value. If their guess is less than the value, your guess was too low. Else, meaning that they guessed the correct value. If they guess the correct value, what do we want to do? Well, we want our flag here to be set to true, because that means they guessed the correct value. So correct value equals true. This means that when it goes back in the while loop, it's going to take the not of true. Not of true is the opposite, which is false. So then it'll stop the while loop, and then it'll be over. So we're going to end that. And then, let's see, your high was too low. And then we're going to end our while loop here. So let's see if we have everything we want in our while loop. So we say guess. Enter a guess here between 1 and 100. It analyzes the guess. Is the guess greater than value? If it is, your guess was too high. Is your guess less than the value? If so, then your guess was too low. Unless it was exactly equal to your value, are we going to say that correct value is equal to true? And then our flag is now set to true, meaning that when we take the not of our flag, we get false, and then it ends that while loop. So then, after that, we can f print f. Congrats, you guessed the correct value of %d. We'll say that's value, so we're going to tell them, oh, cool, you guessed the correct value. And then we're going to say, would you, actually, we're going to say, what should we say here? So we're going to say, what should we say? So we want to ask them to play again. What should our variable be called here? Well, let's call our variable ask is going to equal input play again. Enter enter y if you want to play again. Remember that S here means that they can enter a character or a string. So what we do is we check to see, okay, do they want to play again? Enter Y if they want to play again. So now we have to check and see if they want to play again. Let's check this value of ask we have. So we said ask equals input. Do you want to play again? If ask equals the letter Y, then we know that they do want to play again. But if it does not equal the letter Y, we know that they don't want to play again. So all we really need to check to see is if they don't want to play again. Because currently play again is equal to true. But if they did not want to play again, that means that they would enter anything besides Y. So we can check and see if ask does not equal the letter Y, then what can we say? Well, then we can say that play again is going to equal false. We can end that, and then we can end our giant while loop overall. So this is going to be the final output of our guessing game here, our final program here. We say play again equals true. That's going to be our initial flag. We're going to assume that's always true. We start by saying play again equals true. So this is important because the only time play again will equal false is if they enter something that isn't the lowercase y. But if they enter the lowercase y, it's just going to go back to the top of our while loop and it's going to ask them for another value. And it's going to play again. All right, play again, enter y if you want to play again. But if they don't enter y, it'll go back up. If they do enter y, play again will be false. This value will be false here, and then we'll end our while loop. And then this right here is our mechanism for guessing. So let's actually see and make sure I didn't mess anything up by accident. So let's see. So enter a guess here between 1 and 100. So we're starting our guessing game. I want to guess, let's go right in the middle, 50. Your guess was too low. All right, so my guess was too low, meaning I need to pick a number that's higher. So let's guess 75. Your guess is too low. Okay, 85. Oh my word. You guessed the correct value of 85. Wow, that was honestly really quick, and I did not expect it to be that fast. So play again. Enter yes if you want to play again, or lowercase y. Let's say I do want to play again. If I enter y, all right, it automatically plays again. So let's try again. So 50, your guess is too high. So let's try 25, your guess is too low. 35, your guess is too high. 30, too high. 27, too low. 28. All right, I guessed the correct value of 28. So enter y. Let's say enter n. I don't want to play again. It stops the program. One thing we did forget, one element we did forget, because we want our guessing game to be as fun as possible. We should tell the users how many we should tell the user how many times it took them to get there. So how we can do that? Well, we can have a counting variable in our while loop here to see how many times it took them to guess. So we could say count equals 0, and then every time they guess, we can increment count by 1. But let's see, we don't want to do it if they guess the correct value. Actually, would we want to do it? Actually, would want to do it if they guess the correct value. So at the end here, we can say count equals count plus 1, just like that. So now we have this, and then we can say congrats, you guessed the correct value. We can say fprintf, it took you %d tries. %d, and then that value will be count. All right, let's try one more time just to see. So guess between 1 and 100. I'm gonna guess 50. Your guess was too low, so that means I need to go higher. So 75. Guess was too high. Let's go with 62. Guess was too low. Okay, 70. Too high. 65. Too high. 64. Too high. It should be 63 then. All right, so it took me 7 tries. That's not as impressive as the time I did it in 3 tries. That was pretty cool. I'm gonna say so. I'm not trying to brag or anything. So I want to play again. I do not want to play again. So that means I'm done. All right, I believe I have one more example. I know this is probably getting a little long, so we're going to try to wrap this up a little quickly. So create a script that will find the maximum value of f of x equals negative x squared plus 7x minus 8 using a while loop. So there are definitely much more efficient ways to find this while loop, but this is just for the sake of practice with while loops. Start your search at x equals negative 10 and increment by 0.001 each test. So in this case, we're going to use a while loop to try to see if we can find our value. You know, that's pretty close to, or that is the maximum value. So how would we go about doing this? All right, so let's create a new script here. We're going to call it find max because we're trying to find our maximum value. So this script will find the maximum value of the function specified in the lecture slide. I don't want to type out that function. All right. So how exactly do we go about trying to find this here? All right, so we have a few things we have to look at here. We have to notice that we have our function here that we're starting with. We want to use a while loop, and we want to start at our search at x equals negative 10. So honestly, our first place we want to start is by initializing the certain values that we have. The values being starting with x equals negative 10. It's going to be your best bet here. So let's start by initialize values. So we can start by having our, values. So we can say value is going to equal, actually, just for simplicity's sake, let's make x equal negative 10.0. So we can start by that. So then what would our f of x be? So I'm just going to call fx is going to be, actually, I'm not going to call it fx. I'm going to call it current value because we're going to be comparing two values this whole time. We're going to compare our current value to whatever value we got before. So we can say, let's actually call this previous value is going to equal, let's see, so what's this going to equal here? So the previous value is going to be when we evaluate this. So what function are we looking at here? So we're doing negative x squared plus 7x minus 8. So it's going to be negative x squared plus 7 times x minus 8. So that is going to be the previous value we have. Okay. So then now, what do we want to do here? So what we want to be checking the whole time is we want our while loop to check our previous value, where we're going to start by this being our previous value here. I didn't mean to do that. And essentially, we want our previous value, once we find a point where our current value that we have, meaning the value we're currently testing, is less than the previous value we checked, That's going to be how we know that we're at our maximum value there. Okay, so we want to make sure we use a while loop here. But so we also need a current value that we want to check out. So how are we going to find whatever our current value is at that point? Well, we can find the current value by essentially just incrementing 1 by, you know, negative 10 at that point. So we can say x equals x plus, and then what do we want to increment by? We want to increment by 0.001. So we could say it's going to be 0.001, and then we can say our current value that we're checking is going to be equal to negative x squared plus 7 times x minus 8. All right, so we initialized a few values here. We want to check 2 values because this whole time we're going to be checking 2 values to compare them. We check a previous value and we check a current value. So this value here is going to be checking that x is when x is negative 10. This value here will be checking x is negative 9.999. Yes, that's how many nines I believe. All right, so we have all that. Now we can start our while loop. So what's the condition going to be here? How are we going to know when we found our maximum value? Well, lucky for us, this function that we have looks like this. It's going to be an upside down parabola. So essentially, all we know is that if we're starting at the left side, our values are going to keep increasing. They're going to keep going up. They're going to keep going up and up and up until we reach our maximum value. Once we reach the maximum value, then we know the value is actually going to go down. So if we ever get to the point where our current value is less than our previous value, we know that our previous value was equal to the maximum value. So we know that while current value is greater than previous value, we want to keep looping as long as the current value is greater than the previous value. Let's say greater than or equal to the previous value. Once it's less than the previous value, that's when we know that we're at our maximum point. So that's our condition here. So then what are we going to keep doing? So what we want to do at that point, once our current value is greater than or equal to our previous value, what we want to do is we want to set our previous value equal to our current value. We want to redefine what our previous value is. Then we want to increment x by 1. So x is going to be x plus 0.001. And then we want to calculate a new current value. The current value equals negative x squared plus 7 times x minus 8. All right, so let's kind of analyze this a little bit more. Oops. So let's kind of analyze this a little bit more. So we are saying while our current value is greater than or equal to our previous value, meaning that we're at a point below the maximum essentially, because our current value is less than our previous value. Because we know that the function is going to look like this. So we know this point here is our previous value. This point up here is our current value. The current value will always be greater than or equal to the previous value until we reach our maximum. Once it reaches the maximum, then we go down. When we go down, that means the current value will be less than the previous value. So that's why we picked this condition here. Then we say the previous value, we set it equal to the current value. We redefine what our previous value is. Basically, we're just shifting over another set of points. We add 1 to 0.001. We evaluate the current value. We compare the two. Then at the end, we are essentially going to print max value, and then we're going to print a certain value. So we want to print 2 values. Let's print the value and where it is. So maximum value, we'll give to 3 decimal points at x equals, and then %.3f as well. What values do we want here? Well, the max value is going to be held at, where's it going to be held at? It's going to be held at the previous value technically, because the previous value is going to be the max value, because the current value is going to be 1 just a little beyond that previous value. So we're going to type previous value, and then we don't want to type actually x, because x is going to be 0.001 greater than we want. So we're going to do x minus 0.001. And that will be that. So then if we execute this, it tells us exactly what the max value is. The max value is 4.250 at x equals 3.5. I apologize. It took me a little second to wrap my thoughts and everything I was doing here, but hopefully this makes a little bit of sense. We're saying that the current value is always going to be greater than or equal to the previous value while we're not at our maximum. Once we reach that maximum, that's when the current value is at its highest point. The previous value now takes that value, and then once we move a little past, we move 0.001 past, the current value will be less than the previous value. So we just want to find the point where there's a shift, where we're increasing the whole time, and then we start decreasing. We want to find that shift, because that shift is the exact point where the maximum is. It's kind of a little bit of calculus 1 stuff right here. Now this video has been going on a bit long, so I'm just going to clearly demonstrate what infinite loops are. So this is a main concern that arises when using while loops. It's the possibility of code that contains an infinite loop. An infinite loop, like the name suggests, is a while loop that never ends due to the condition specified never reaching a point that results in a logical false. Meaning that you set a while loop, you have a condition, and that condition never equals false at any point. It just keeps on going because a while loop will keep going. Infinite loops actually show up in debugging quite a lot more than you'd actually expect. You would think this would not happen, but when you're writing code and you use a while loop, it's actually a really high possibility that you're going to have an infinite loop at some point. You should always keep an eye open for one. In MATLAB, the command prompt yields a nothing, and the greater than signs can't be seen, so you're most likely stuck in an infinite loop. To exit the code, if you're stuck, press Control-C. If you're ever stuck in an infinite loop and you want to stop, you don't have to shut down MATLAB completely. You can just type Control-C. But let's do a couple examples of this real quick. Let's just type them up real quick. So this is just going to be infinite loop. So how can we type an infinite loop? Let's say we have a value. That value is going to equal 1. Let's say we want to print off the numbers 1 through 10. Okay, kind of like our previous example. So while value is less than or equal to 10, fprintf, we're going to print our value. Let's say we accidentally forget to increment value by 1 each time. If we never increment value by 1, value will always equal 1. If value always equals 1, value will always be less than or equal to 10, meaning this while loop will never stop, meaning you're just going to print off a bunch of 1s. So just for fun, let's run this. Oh yeah, let's actually save this real quick. So Control save, infinite loop 1. So let's see what happens here. If I type infinite loop 1. So you kind of can see my, it's kind of going a little bit crazy here. You can see there are a bunch of 1s that are coming up. This little slide bar is going on. Yeah, because it's going to keep printing 1s. The while loop is never stopping, and right now I might have a memory overload at some point. But so this just keeps going because I never incremented by 1. This is an infinite loop. If I don't do anything, this will never end, and this will go on genuinely forever until MATLAB breaks. But I can stop if I click Control-C, operation terminated by user. So if you ever in a while loop like that, you can get out of there just by going ahead and doing that. Let's see, what's another example of an infinite loop that we can have real quick? So new script. Yeah, so let's see, what's another problem we could have here? So let's say I make a while loop. I say while true. So this is already buckets of problems because we could see while, and I just put true. Unless I like break out of this while loop, true's never going to equal false. So I could say while true. So if I just put the keyword true, I don't even have to list a condition. I could just say true. This thing's never going to stop. It's just going to keep on printing forever because there's no way that while the condition will ever be false. All right, so let's try running this one. Yep, so you can see we are stuck again in an infinite while loop. So these ones are kind of obvious to tell that they're while loops because, you know, they're printing something. But let's say I'm back here in my infinite while loop. Let's say I'm trying to do like some calculation, for example. I don't know. Let's say I have some calculation. I can say value equals 1. And then let's say I just want to like keep adding 1 or something. So I can value equals value plus 1. Let's say I do this. This might not be obvious that we have a while loop going on here. So I'm not printing anything to the screen. But you can see these double greater than signs are not showing up. That means that the program has not executed at any point. So that means we are stuck in a while loop right now. It has been adding 1 this entire time, and it's not breaking out of it. What I can do, I recognize that this is an infinite loop because I don't see those 2 greater than signs. So I click Control-C, operation terminated. So while loops here, essentially, they're extremely useful. They're used when we want a condition and we don't know exactly how many times we want to go through that loop. In thankfully, there is a way that programming languages have allowed us to use conditions instead, but you need to be careful when you're using while loops and debugging, or else you can run into an infinite loop in your program, and the last thing you want to happen is to be stuck for so long and you have an infinite loop and no one's happy at that point. So thank you all for watching. I appreciate it.